Alright, here's a couple of questions that involve combinations or permutations or something like that. The first question says, how many 7-digit phone numbers can be formed from the digits 0 to 9, assuming that the first number cannot equal a 0 or a 1? It also doesn't say that you can, or it doesn't say that you can't repeat. So it looks like repeaters are in. So what I like to do with a question like this, if I'm dealing with a 7-digit number, I like putting just sort of 7 slots in. And the first number, they say it can't be a 0 or a 1. That leaves 8 other choices, right? 2, 3, 4, 5, 6, 7, 8, and 9. In the second slot, it can't be a 0 or 1 either, so there would be 8 choices for it as well. And then in all the last slots, I can use any number that I want. So I could use 10 numbers here, 10 there, 10, 10, and 10. Therefore, in that first part of the question, I would use the fundamental counting principle and just multiply all of those numbers together. And that would give me the total number of 7-digit phone numbers that can't start with a 0 or a 1. And then in the next question it says, accordingly, how many telephone numbers can there be within a given area code before the area needs to be split with a new area code? So say for example in our area code right now we're 403. Maybe I shouldn't have put those numbers there because those aren't how many numbers could go there. Those are the actual numbers. So the numbers are, say we start with an area code of 403. That means I can only put 1 in that slot, can only be a 4. 1 in that slot can only be a 0. 1 in this slot can only be a 3. And then these numbers after can be anything. And so I could fit 10 there, 10 there, 10 there, and 10 there. So 10 multiplied by itself 4 times all these ones, that would be about 1,000 numbers. Is that right? No, I need another 0. 10,000 numbers before I'd have to change my area code. And that's what happened to us in Alberta. Now we've got 2 or 3 area codes in the province just because we needed so many phone numbers. Here's another question that looks at similar kind of thing, and again I find this fundamental counting principle really quite useful. Just putting in how many can go in each slot. So how many code symbols can be formed using 5 out of 6 letters if the letters, okay, just a second, 5 out of 6 letters. Looks like I've got 6 slots here. I only need 5 of them. Don't need that one. If the letters are not repeated. So here's A, B, C, D, E, F. So in the first slot, I have 6 letters I could put in. And if they say you can't repeat, then in the next slot, if I've used one, I only have 1 more. Or I have 1 less than this one. And then in the next slot, I would have 1 fewer, again 1 fewer, 1 fewer. So if I multiply all those, that would tell me how many different arrangements or symbols could be formed using 5 of those letters if you can't repeat. Now if you can repeat, then in the first slot you can have 6 letters, A, B, C, D, E, or F. In the next slot, if you can repeat, I've got 6 more that I can use. And similarly in the rest of the slots, again I only have 5 slots. I shouldn't have put 6 in there. So similarly here I've got 6, and I've got 6 if we're repeating. So this would be 6 to the 5th, whatever that turns out to be. Okay, letter, so this was A and this was B. How about C? What's it say? No repeats, but you have to start with a D. So if I have to have a D here, it means you only have 1 option to put there. But then the next one, it says not repeated. So the next one, if I've already picked a D, I can't use a D again, but I have 5 other letters that I could use. So I'd have 5 there. If I can't repeat, that leaves me with only 4 in the next slot, 3 in the next slot, 2 in the last slot. Multiply that together, 120-ish, something like that. In the last one, again not repeated, but they have to be in with a D and an E. Okay, so this has to be a D and this has to be an E. So I only have one way of doing that. If they can't be repeated, then I'd only have 4 letters left. And then again, if I can't repeat this one, I'd only have 3, and then the last slot 2. So there'd be 24 different code symbols if I couldn't repeat and I had to start with a D and an E. Okay, hopefully that gives you a little bit of help with working out those kinds of permutation questions.